Dear all, my name is Lander Galdos from Mondragon University in the north of Spain, and together with Matrix Tool Company and Fagoras at the Press Builder, we are leading the Smart CAMBER project. Smart Office contacted us to ask for a presentation to give you good advices how to submit a smart proposal, and this is the aim of the presentation. I will not go in deep details in technical aspects, but I will rather focus in giving you some basic rules for the smart presentation. What is CAMBER? Okay, CAMBER project and the purpose. You see two people here polishing a huge die. Okay, and their work won't finish before all the surface in the side panel of the car is in blue. So they take a pre-cut, they paint both sides, they do the stamping, and both active surfaces in the top and the bottom needs to be blue. Okay, and this gives us small errors, details like 0.1 millimeter gap between two surfaces, and you will see not a perfect blue surface. So you will imagine that this is very tough work and very time consuming. Okay, and this is why we applied for this project. The active surfaces of the tools nowadays are cambered using previous experiences, again, previous knowledge, and the elastic deformations that this tool and presses are suffering are not taken into account. Okay, so you can imagine that a small deviation, elastic deviation of the tool, they can give us really big extra time. Okay, when setting up a tool like this. If you go in details, okay, approximately the 30% is of the cost is the polishing and setup, and an average 28 weeks are needed for the setup process. Okay, so this is definitely really high. Okay, so the aim of the project is to reduce 30% of the current total setup time and the 10% of the cost of the tools. Okay, our approach is to have a stronger design phase and to have a methodology where this cambering with this tool compensation is not done with previous experiences, but with let's say engineering and knowledge-based methodology. Okay, so the current flow chart or flow work, okay, we would increase some weeks in the engineering phase, okay, but we will save time and cost later. Okay, and for that we are assuming that we need tool press FEM. So what is tool press? So we need to have press and the tool simulated, okay, while they are working. Yeah, okay, and to see how this surface is deformed to take decisions and to have an advanced cambering methodology. Okay, and all this is based in a smart sensor that we are going to develop in the process that can be clamped in the tools and can be clamped in the presses to show us how the surfaces are deforming elastically. Okay? With this sensor, we can also monitor what we did in the engineering phase and what we have in the workshop. Okay, so that we can feedback these loops in the coming optimization loops of the tool. Okay, and this is the approach. Okay, how we built the consortium, how Camber started. Okay, it's very basic. So we had an idea to construct something measuring bar which is simple, cheap, and not heavy. Okay, portable, something that is portable. And the idea was to have a bar with several strain gauges that is following the shape of the press, of the bolster or at the table, and also the ram. And knowing this strain, we can convert this to millimeters and have the spatial, let's say, geometry that the tools and the press are taking. Okay, and with this basic idea, we met in ISAFRON conference with Johan Pilthammer and Mats Sigman from Volvo. Okay, and in front of a beer. Okay, after some discussions about the papers. some papers, we definitely thought that this could be a good approach. Okay? And we started doing the consortium. So we end up with a consortium where Volvo Car is the OEM. Okay, we have Matrici as tool company in Spain, which it does big tools. Fagorasate, which is doing presses for metal forming for the automotive industry, high tonnage presses. We have Proximion, which is a sensor developer that is really expert developing fiber-based sensors. Okay, and then we have Mondragon as university, SVDA in former times RISE now, and BTH University as technology suppliers. Okay. I will stop here for giving you the first advice. Okay, before contacting the partners, please do your maths. Okay, and why do your maths? You have some eligibility criteria, so some of them are easy. These two industrial companies from two different participating countries. Of course, you will have to counter some two companies if you are thinking in a smart project has a civil purpose. You need to do it like this. Okay, so only civil purpose is funded. Then you need to know that the Smart is funding a strong market-oriented project, so be careful with that. Okay, we need products at the end of the projects. Okay, and the last two, which are quite important, every participant contributes with less than 66%. This is normally easy, but be careful with the last. Every participating country contributes with less than 66%. So if you have a very advanced project with a lot of partners in one country, this can be a problem later for the funding, and you have really unbalanced money distribution, let's say. For the proposal, be careful because we have two steps and two deadlines. So double check the deadlines and mark them in the calendar. You have a project outline first, and then you need to send the full proposal. Okay. Please contact the Smart office and your national contact points from the very beginning. Okay. Why? Smart will help you a lot. Okay. And you need to know in your national contact points which is the deadline if you are positively evaluated Smart, so that you send a national call, because you have to present it in Smart and also in your country. Okay. And this is important because every country has its funding rules, so you need to know the deadlines, the funding rules, to also do your maths here. Okay. Another advice is to select a suitable starting project for all of them, for all of the consortium, and I'd advise to choose a date when all the partners will have a final answer from their national contact points, so that after all are funded, you start the project. Okay? Regarding the paperwork, okay, I have submitted quite a lot of proposals in Europe, okay, and I can say that it's relatively small, okay, and it's much less than an Horizon 2020 conventional call. So yeah, I fully advise you to try the Smart community and the Smart calls, because it's a good opportunity. Management and reporting, okay, this is classical, do teamwork like these guys are doing here, okay. 1 + 1 is much more than 2, okay. I fully advise you to meet at least every 6 months, all the consortium, and monthly at the national level. Create FTPs or sharing folders for putting all the information together, and be careful because you have reportings. You have one reporting in month 6, and then every year, and the final one. Okay, and be in contact in Smart. Okay, these people are really helpful, and they are answering you really fast the email, so they help us a lot. So yeah, use them. Regarding the CAMBER, I will try to show you how is the status in our project. Okay, we wanted to have press and tool deflection measuring devices, and this is almost completed and validated. We wanted to have intelligent and try out presses. Okay, this is in progress because this will be embedded in the new presses. Okay, And using this also measuring sensor, we want to supply machine monitoring services for tier ones and OEMs, because knowing the deformation of the bolster and the head, we can do the health monitoring of the presses. So this is in progress also. And we can say that we are almost done with the new CAMBER methodology based on finite element modeling. Okay, and I will show you some figures to, yeah, so that you can have a very fast impression of the project. Okay, this is the sensor we created. Okay, which is long enough to cover a press table. It's based in fiber optic, where we are using 16 FVGs, so like 16 strength sensors, let's say, that are in the same fiber. Okay, I'm not going to details in that area. Okay, and is able to capture 2.5 kilohertz. Okay, so this is done. The concept was validated in our servo mechanical press here in our labs for 100 tons, and later in a trial press of 2000 tons, and the concept is working. So we are very happy. Using this information, okay, we have built full couplet models with their press ram, press table, and bolster. Okay, and using the information that we are getting here, we are validating this project, this model, sorry, but also we are using them to create simple substitutive bolster and table models, and also substitutive RAM models using, let's say, simple models, so that we can now put here a tool, do the virtual stamping, and see what is happening with the table, with the RAM, and with the tool. Okay, and we did this for two components now. The door inner is ongoing in Volvo. I will show you probably the most funny one, which is the side panel made in aluminum. Okay, so you can see how the tool is deformed elastically, and this is going to be used to remill the tools and to quantify the improvements in the setup. Okay, and with this, more or less, we will end with our project with a sensor, with intelligent process, and with a really engineering-based CAMBER methodology that will cut down the setup times. Okay? And that was all from my part. So I hope you learned something about how to build a project, how to manage it, okay, how to be in contact with your national contact points and with the smart office. If you have any doubt, please contact me. You have my email address there. And see you next time. Bye bye.